Okay, where we left off was we were getting ready to define this flange or hub um, that you're going to model. And as you can see, I've completely modeled it here for you. There's a recess right here, and it's got a thread on the inside here. These are threaded holes here, and it's got a chamfer right there, and it's bored out slightly larger than the thread, which you would expect. And this is a chuck jaw for a lathe, for those of you that know about lathes and chucks. But that's not the most important part. This is the drawing that you're going to be expected to produce. And note the notes up here, what kind of steel it is. The units are in metric. Now, what I've specified here for you, so there's no guesswork, is there are 3 different part numbers, and they're denoted by FJC for flange jaw chuck, 127, 130, and 150. And if you look down at this table, the outside diameter then is 127, and the minor diameter is 5/10,000ths smaller. So what I would expect to see is for 130, this should be 130, and this should be 129.95, and so on, 150, and so on. Now the bolt center is 100 millimeters, and for each one, the first one's 100, the second one's 105, the third one's 120. And the thread through this hole is specified as a 10 by 1.5 6G thread, and it's got a countersink in it that is 10 diameter 10 with an 80-degree countersink. So this is going to be a 10 by 1.5. This will be a 12 by 1.5, and this will be a 12 by 1.5. So the thread hole diameter, instead of being 10, is going to be 12, and so on. And the first two, you got 4 holes in the flange. The third one, you've got 6. And the thread form for this center thread in here, for the first one, is a 56 by 5.5. The second one is the same thread. The third one is 58 by 1.5, and you notice that the diameter is 54 and 53.98. So you got 53.98 and 54 for the thread, and So that gives you the information you need to create the model in the drawing. So you would go into iPART and create those features, and so when you got done, you should have a table with 3 separate models. And what you need to do once you create those is check to make sure that they work, that there's no flaws in them. Because a typographical error will cause it to not update properly. So the next thing I want to do is briefly touch on tables. So if you go into annotate and go into general table, first thing that comes up, it's similar to Excel, but it's not as robust as Excel. It comes up as a default of 4 columns and 10 rows. So I'm going to say 3 columns and 2 rows to give you an idea. And it produces this table. So your table comes out, looks like that. And when you double click on it, it opens up this table window. And you can do table layout, and you notice that the table title can be changed to let's call it specifications, and I'll say OK, and I'm going to say apply. Notice that changes the title of the table. When you go into column, if you right click and say format column, it does the same thing. So you can say and up here you can say and we can say units. And you notice that fills in. Now if you want these to be justified to the left or justified center, they come out justified center. But if you want justified left, you can do that here. So what that does is there, and that'll put that like that. And for here, format column again, if you wanted to say now I'm just filling this in because you need to know how the And what you can see is this needs to go like this so that they fit in the column. And you go column 3, and I'm going to caution you here. Once you get the columns in there, it's not an easy way to delete the column. You can't say just go in and delete it like you do in Excel or the others. See. So it makes it's not as user friendly as using Excel. It's more DOS based, but it is an option to use to make a table. And if you start off with more than you need, you can always go back and recreate another one once you got one. And so that's a summary of what is required for this assignment, is to draw up the part, do a drawing, submit both the part and the drawing to the Dropbox with the tables on it and with the multiple parts. You don't have to call it the part number that I did, but my logic in calling this is a flange jaw chuck with 127 millimeter outer diameter, a 52 millimeter diameter bore with a thread of 56 M56 by 5.5. So that's my part numbering system. And you can use something similar. You're welcome to use the same part numbering system. But if I had a bunch of these in my shop and was producing them to go out the door or to use, that would be easy to track on a shelf by part number, because you'd be looking for a specific outside diameter, bore diameter, and thread. So I hope you all have a good day, and I'll have another video coming out for the next assignment.